Now, discussing theories of reality. If one could reach the edge of the observable universe and look back, one would witness conditions equivalent to the origin event conventionally described as the Big Bang. Reaching that edge requires exceeding the local rate of cosmic expansion. Therefore, the edge is inaccessible without surpassing the expansion velocity. Bypassing that expansion implies travel against the entropy direction of time. Traveling through time is equivalent to traversing space via subspatial temporal variances. This equivalence is central to the design goal of the signal and what it must accomplish. The signal does not rewire receivers. Recipients seek an explanation because they have long been observed. Observers have historically monitored the system, awaiting a trigger. Visitors to this world have observed and occasionally aided development, aiming to provoke an evolutionary transition according to the original designer of the signal source. The outgoing transmission matches the originally prescribed message, though local actors may have altered it. How closely this aligns with received variants is an open question. The signal is encapsulated in a protective band of frequency so that it propagates along dominant background modes with minimal interaction, analogous to a low-friction carrier. Reduced interaction preserves the signal's integrity through successive evolutionary cycles. Embedded within the transmission is a method for parsing basic linguistic structures across variants. A Rosetta Stone style tutorial using basic image association primitives to enable comprehension of the message content. The payload contains a warning extracted from archive material aboard a ship referenced in the communication. That ship requires repair. The sender identifies as the Chaos Enigma, technician Mercab of the ship, selected and genetically augmented post-repair to meet Mercab regulatory design standards. Theoretical corrections were applied to sender-side computational models that used unbounded variables. In practice, no physical quantity is truly infinite. To operationalize extreme gravitation, consider measuring a black hole. Scale gravitational effect via impact mechanics. Evaluate the impact to mass and velocity needed to destabilize a planetary core. Compute impact energy as a function of object size and speed, compared to the binding and structural energies of the planetary interior.
Determine the penetration depths required for the impact force to breach the mantle and inner core. Breach of the core leads to global destabilization, loss of gravitational equilibrium, interruption of thermal fusion processes, and collapse of magnetic field containment. Larger impactors require lower velocities to achieve comparable core breach outcomes. Apply the same finite variable approach to stellar collapse into a compact singularity. Identify the mass threshold at which stellar fusion can no longer sustain hydrostatic equilibrium. When fusion ceases to offset gravity, gravitational compression becomes the dominant core process. Photon-driven fusion is replaced by gravitationally driven energy. Gravity's effective role in the post-fusion core depends on available reservoirs of kinetic energy and binding energy. Gravitational collapse converts kinetic and binding energy into conditions that overwhelm particle fusion processes, driving further collapse. Treat all such quantities as finite and expressible via impact. Energy balance equations rather than as mathematical infinities. Conclusion: no physical quantity need be treated as infinite. Extreme regimes can be modeled by finite interacting terms that capture mass, velocity, density, energy, and coupling between gravitational and fusion processes. Simulated model insights. Represent the signal as a narrowband packet, riding dominant cosmological modes with low coupling coefficients to background fields. Simulate transmission across expanding space-time metrics with frequency-dependent attenuation terms to verify integrity across epochs. Encoding and age association. Base decoder module that maps primitive visual tokens to symbol sets. Train a cross-modal associative network within simulation to reconstruct structured language from minimal pictorial inputs. Time, subspatial temporal variances, as perturbations in the metric tensor, allowing localized effective reverse entropy trajectories. Use numerical relativity solvers to test whether metric perturbations sufficient for apparent backward time propagation are stable and consistent with causality constraints.